In the previous videos, we discovered that natural log of x can also be defined as definite integral from 1 to x of 1 over t dt, and we also showed that this definition and the definition of log base e of x are precisely the same thing. So now I'm going to use the definite integral definition of natural log of x to figure out what derivative of natural log of x is going to come out to be. So derivative of natural log of x is derivative of this function, which is same thing as natural log of x. And using second fundamental theorem of calculus, derivative with respect to x of definite integral from some constant to x of some function dt is same thing as when you replace this t with x. So the answer is 1 over x. So derivative of natural log of x comes out to be 1 over x, which is quite exciting because now we can find antiderivative of 1 over x. Now let's think about what we would get when we differentiate natural log of absolute value of x. And you may say, why do we need to know this? And I'm going to, as we are about to find out, by figuring out this derivative, we can actually expand what integral of 1 over x dx is going to be. Instead of simply saying it's natural log of x plus c, which is only defined for values greater than 0, we can now define it for values that's just not equal to 0, less than 0, and more than 0. So this can expand what the domain of our antiderivative if we can prove that this thing is equal to 1 over x. So let's do just that. Natural log of absolute value of x for x greater than 0 is equal to natural log of x. So when you differentiate it, you should get 1 over x. For x less than 0, you have natural log of negative x, because for negative 1, absolute value of negative 1 is negative of negative 1 or positive 1. So, and when you differentiate this using chain rule, you're going to get 1 over negative x times derivative of negative x, which is negative 1. So you also get 1 over x. So derivative of natural log of absolute value of x is indeed 1 over x. And we can say that integral of 1 over x dx is natural log of absolute value of x plus c. So we can include more points in our domain. And as you realize, 1 over x is defined for every x not equal to 0. Natural log of absolute value of x is defined for all x not equal to 0. So the domain of antiderivatives are the same, and the original functions are the same, which is nice.